All right, let's state the equations that we have. Well, this is a simple problem with basic equations for the capacitor. So we have a C equals, let's state these equations. C equals Q over delta V. That's one of them. We also have the equation for the electric field, and that would be sigma over epsilon naught, which is the same thing as Q over epsilon naught times A. We also have this one, capacitance equals epsilon naught times A over D, and that might do it. Just remember that if this is a capacitor, say positive charge, say negative charge, here's your Q, here's D. D is the distance between the two plates. There's also voltage potential difference between the two plates. Okay. All right, so for this specific problem, let's set up the given. Let's see what we have. We have distance D between the plates. Well, how about this? You should pause the video and you should solve the problem yourself. And then you can play the video and see if your solution agrees with what you will see here. Okay, so distance D is 4 millimeters. That means 4 times 10 to the negative third of a meter. Each area is 9 millimeters squared, so A equals the area of each plate, so A equals 9 millimeters squared. I have to convert this to meters, so let's do it now. So what I have is 9, and then here's a millimeter times a millimeter, because this is millimeters squared, and that amounts to 9 times 0.0 hang on a second. It's 1000. Millimeter is 1000, so this should be 0.01 of a meter times 0.001 of a meter, right? 1000th of a meter. 1000th of a meter equals 9 times 10 to the negative. We have 3 here, we have 3 here, negative 6th of a meter. All right, let's make sure that we're good. Okay, so we have the area, we have the distance between the two plates, we have the charge, Q equals 50 microcoulombs, so this is 50 times 10 to the minus 6th of a coulomb, and we can keep it like that. All right, the unknowns. So what I'm looking for is the capacitance, and I'm looking for the potential difference, and I'm looking for the electric field. All right, well, what do I have? What do I not have? I can calculate capacitance. Let's start with that. So C equals epsilon naught times A over D. Epsilon naught is just a constant, 8.85 times 10 to the negative 12 times the area, which is 9 times 10 to the negative 6th, divided by the distance, which is 4 times 10 to the negative third, equals. All right, so let's calculate this, see what we get. All right, so what we get for this is 1.99, so basically 2 times 10 to the minus 14th farads. This is the capacitance of the capacitor. Okay, so we have one thing. Now we can calculate the voltage, because I can use this equation, C equals Q over delta V, which I can transform into delta V equals Q over C. Now Q is 50 microcoulombs, this divided by what I just got, capacitance, 2 times 10 to the minus 14. This is easy enough, we can do it in our head. So we're going to get 25 times 10 to, and then what we get here is 8 to the 8th volts. So 25 times 10 to the 8th volts. Let's make sure that's true. And it is. Okay, so we have that. We have the potential difference, and the last thing we can do is the electric field. So the electric field, the equation for the electric field, well, I could do it two different ways. I could use this. I could use this equation, Q over epsilon naught times A, but a quicker way would be to use this one over D. Both of these equations will give me the same result, but I'm going to use this because this will be easier. So this would be 25 times 10 to the minus, 25 times 10 to the 8th divided by distance D, which was 4 times 10 to the minus 3rd equals, so let's calculate this. Okay, so what we get here for the electric field is 6.25 times 10 to the 11th volts per meter, or newtons per coulombs, either one will work. Okay, so here's your simple problem 1.